Hello students, welcome back to Future Foundation. Students, in this video of basics, let us come to the next point. So we are going to discuss point number 8, which is if a1 upon b1, comma a2 upon b2, comma a3 upon b3, and so on, comma an upon bn be unequal fractions of which the denominator are all of which the denominators are all of the same sign, then the fraction a1 plus a2 plus a3 plus and so on up to an upon b1 plus b2 plus b3 plus and so on up to plus bn lies between the greatest and the least of them. What I'm saying, let us see by its proof. Let the fractions lies in the inequality. Let the fractions lies in the inequality a1 by b1 less than a2 by b2 less than a3 by b3 less than and so on less than ag by bg, and also a1 by b1 is greater than al by bl. So here al by bl is nothing but the fraction having least numerator and least denominator, and a1 ag by bg is a fraction having greatest numerator and greatest denominator. So now let ag by bg is equal to k, then a1 by b1 is less than k because k is greatest, so it implies a1 is less than kb1. Similarly, A2 is less than KB2, A3 is less than KB3, and so on. Right? Now, A1, A1 plus A2 plus A3, and so on, plus dot 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 plus AN upon B1 plus B2 plus B3 plus dot 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 plus Bn. So if A1 is less than KB1, A2 is less than KB2, so this implies this whole fraction will be less than KB1 plus KB2 plus and so on up to KBN on B1 plus B2 plus B3 and so on up to Bn, right? Or less than k times b1 plus b2 plus and so on up to bn upon b1 plus b2 plus and so on plus bn, right? So it is less than k, and which is less than ag by bg because k is equal to ag by bg. So, and now let a1 plus a2 plus and so on up to plus an upon b1 plus b2 plus and so on up to plus bn is less than ag by bg. Right, say this is 1. Now let al by bl is equal to sum m. So a1 by b1 is greater than m because al by bl is least, right? So a1 is greater than mb1. Similarly, a2 is greater than mb2, a3 is greater than mb3, and so on up to dot dot dot. So E1 plus E2 plus and so on up to En by B1 plus B2 plus and so on up to plus Bn must be greater than m times B1 plus B2 plus and so on up to Bn upon B1 plus B2 plus and so on up to Bn. So it is greater than m, right? So we can say E1 plus E2 plus and so on up to plus An by B1 plus B2 plus and so on up to plus Bn is greater than m which is AL by BL. So this is A2. So if we combine first and second, then we conclude that the ratio A1 plus A2 plus and so on up to plus An by B1 plus B2 plus and so on up to plus Bn is greater than AL by BL and is less than AG by PG. So this is what I have written in the above statement. Now let us take a question. Prove that summation 1 by root over k, where k is equal to n square to n plus 1 whole square, is lying between 2n plus 2 upon root over n square to 2n plus 2 root over n square plus 2n plus 1. So we have to prove this statement. So if we write this L in expanded form, then it will be 1 by root over n square plus 1 by root over n square plus 1 plus 1 by root over n square plus 2 plus and so on up to plus 1 by root over n plus 1 whole square, right? As k is moving from n square to n plus 1 whole square, as simple as that. Or L can be written as 1 by root over n square plus 1 by root over n square plus 1 and so on up to plus 1 by root over n square plus 2n plus 1. So students, what we are doing in this L, or in terms of L, we are increasing by 1 in the radical, under the radical, right? We are starting from n square plus 0 to n square plus 2n plus 1, right? So number of terms in L will be 2n plus 2, because we are moving from n square plus 0 to n square plus 2n plus 1. So they are 2n plus 2 terms. And also if we are searching for least term, so what is least? Least term will be having greatest denominator, right? So greatest denominator is contained by last term. So this is least, right? So this will be greatest. And what we have discussed so far in this point, we have discussed, so we can write L. So let 1 by root over n square is equal to k. As 1 by root over n square is greatest, then 1 by root over n square plus 1 is less than k. Similarly, 1 by root over n square plus 2 is also less than k, and so on, right? So this whole, this whole L can be written as less than k plus k plus k and so on, right? And how many these keys are? 2n plus 2. So L is less than 2n plus 2 k, means L is less than 2n plus 2 by root over n square, because k is equal to 1 upon root over n square. And also let 1 upon root over n square plus 2n plus 1 is equal to m, because this 1 upon root over n square plus 2n plus 1 is least. So 1 by root over n square will be greater than k, greater than m. Similarly, 1 by root over n square plus 1 is also greater than m, and so on. So this L must be greater than m plus m plus m, and so on up to m. And these m are 2n plus 2 in numbers. There are 2n plus 2 m's. So L will be greater than 2n plus 2 m's, implies L is greater than 2n plus 2 by root over n square plus 2n plus 1, right? So from these two we can conclude L lies between 2n plus 2 upon root over n square to 2n plus 2 by root over n square plus 2n plus 1, and which completes the proof. So students, let's meet in next video. Till then, bye bye and take care.